Hi, this is Tavi Greiner, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
Program complete. Enter when ready.
The curtain of night is drawn back. The telescopes are trained. The domes are open. The audience is set. Now, step into
you on the other
the
side.
event horizon.
4, 3. Good evening, everyone, and welcome to the Event Horizon here on Astronomy.fm radio. That means it is another Friday night, and this one happens to be August the 24th. 2018, 9 o'clock in the evening for those of us here in the eastern portion of North America, also known as Saturday morning, August the 25th. That would put it about 1 o'clock Universal Time, Saturday morning. So we're live for the next hour. I want to welcome everybody. My name is Marty Coons with my co-host.
Good evening, it's Nick Yvetz. 2 Echo Zero Lima Uniform November.
That's your radio call sign, right?
Oh yeah. Oh yeah.
Gotcha.
And what's the best thing about being a red amateur? Quite a few red amateurs are also astronomers, and quite a few astronomers are also radio amateurs.
Mm-hmm.
There's that noise about it. In fact, what gets me is people like, one of the Yorkies, she's a radio amateur and an astronomer.
Mm-hmm.
Let's think, there's a professor at the University of Lancaster,
mm-hmm.
who's very well known. He does Ask an Astronomer, and he was also involved with the Jodcast for a while. He's a radio amateur as well. He's I think he's a G4 or a G3, I can't remember which.
And you can talk to the International Space Station.
And I can talk to the International Space Station, yes.
How nice.
Because what it is at the moment, well, it's assuming that there's somebody in the Russian, in the Soyuz module where the Russian 2-meter transceiver is, because the American module, or the cupola, is out. It has no amateur radio capability because they're waiting for someone to smuggle a handy-talkie onto the next American flight.
Yeah. Would a CB radio work?
No.
Okay.
The reason they're using 2 meters is, actually there's multiple reasons. 2 meters amateur radio has actually proven itself, because for a long while, the actual official radio system of the ISS was a Kaputnik, and the Russian commander at that point refused point blank to use it to speak to Moscow. He said, I would much rather use fellow radio amateurs and have them do phone links for me into Moscow and into Baikonur, because that way it's more guaranteed I'm actually going to get to talk to somebody.
Nice.
So the other thing is, what people don't know is Cape Kennedy actually has its own 2-meter repeater.
Mm.
And during the era of the space shuttle, some degree I do miss the flying brick, but that's another story. But the thing is, what it is, the space shuttles were all equipped with 2-meter transceivers, mm-hmm. because all the astronauts that go up to the ISS are given amateur radio licenses by their respective countries.
Uh-huh.
Now, the other good thing, of course, is during a launch, the repeater is locked off. So regular amateurs like myself, we can listen on it, we cannot transmit on it. The reason for that is that it is a fail-safe system, that if the actual radios on board the shuttle, the official mm-hmm. radios don't work or fail, they can use 2 meters mm-hmm. and go straight into mission control at Kennedy and in Houston to talk direct to Capcom using amateur radio.
How big is the unit on the space station? Is this like a handheld?
It's a handheld walkie-talkie.
Handheld radio.
It's a handheld radio.
Okay, and that's
all it needs to be, because what it is.
That'll cover the distance to the surface.
Oh God, yes.
Okay.
So I've got it's 5 watts.
Okay.
5 watts power. Now, when you consider that basically they're pointing the antenna down at the Earth, it's
Is it directional?
No, it's omnidirectional. But the signal being the way the signal works is it's line of sight.
Okay.
So all the ARIS missions, what happens is you have a set time to accomplish as many questions from school kids via amateur radio to the ISS and to get a response.
Basically, horizon to horizon.
Yeah. So as the ISS goes over, rises, transits, and sets, you have that period of time to actually talk to the ISS.
Mm-hmm.
The other thing is they actually have a repeater on the ISS. The repeater is open to all radio amateurs. It's set to the individual frequencies for each region on the Earth, because there's 3 regions as set up by the International Telecommunications Union. Each region has a slightly different frequency.
So basically, you can get over the horizon a little bit with the repeater.
You can actually get with the repeater on board the ISS. You can actually, well, it's kind of like the libration on the moon. Really,
Mm-hmm.
you get to peak a little bit further than you would normally.
Mm-hmm.
So even with just 5 watts, a handheld radio and in a lot of cases, a lot of people use a handheld Yagi antenna, which is how to describe it? Think of your TV antenna.
Mm-hmm.
You used to have until everything went digital. Can you DX? Yeah, effectively it is kind of DX, because by bouncing your signal through the ISS repeater, you can reach countries you wouldn't normally get on VHF. VHF is very much a local thing. Now, for instance, I use a repeater in the city of Schenectady. It's in the highest point of the city.
That's around the east coast of North America.
It's in upstate New York.
Yep.
It's about 15 miles from the state capital, Albany.
Okay.
Now, being that I'm just on the edge of Albany and Troy, when I'm working into the repeater, I'm using 50 watts. I actually live in a black spot for the repeater. So for me to make the trip, I have to use the legal power, which for me is 50 watts. Now, most people use 5, 10, etc., depending on where they are. Now, to give you an idea of how good the repeater is, this repeater can actually be worked from Vermont.
Okay.
So you can be in the middle of Vermont. You can actually work into the middle of upstate New York,
Which is quite hilly in Vermont there.
hilly. So most people live on top of the hills
Mm-hmm.
and line of sight. So
You do have to be on the near side of the hill instead of on the back of the hill, though.
yeah, or at the summit.
Okay. Yeah.
Summits are always better because that gives you an even better line of sight.
Mm-hmm.
So basically, if you're in Battleborough, you can get into the repeater.
Mm-hmm.
The furthest I've worked the repeater is just south of Hudson in upstate New York. So
Okay.
I'm on the southern side of the city of Hudson, which is heading towards New York City.
So basically, you can't get it over the horizon with the radio because it's line of sight. But what you can do is bounce it off of an antenna that can see over the horizon. That's like most of the way there. And then you can kind of basically, can you bounce it around the world?
Theoretically, yes, because you can use satellites.
Okay. Oh, if you use a satellite, right. But how about on the ground? Can you bounce a radio signal that can't go over the horizon? With repeaters, can you bounce it basically around? Until you hit the ocean, maybe.
There are 3 cravats to this.
Okay.
First one is Aurora. You can use an Aurora to bounce a VHF signal.
Okay.
You can use the ion trail from a Meteor.
Yeah, a short one.
But trust me, you can get a lot further with that.
Okay.
So, and the other way you can do it, I'm trying to remember, because I know this, you can bounce it off the moon.
Oh,
Believe it or not, you can bounce a signal off the moon. It was called Project Diane. It was back in the 1950s, and they were looking to use a radar based in the US using the moon as a reflector.
That's the big equipment, though. That's not the handheld stuff, though, right?
But actually, I have a transceiver unit in my car.
Mm-hmm.
On 2 meters, it's at 50 watts. On 70 centimeters, it's down to about 10 watts. The higher, the smaller the actual wavelength of the signal, the more, I suppose you could say, the more interesting it gets. Think about this. The device you have in your microwave can actually transmit signals. That's why it's all shielded. If you stood in front of your microwave and it was just a plastic surround, you would get fried.
Oh, cooked
Nicely through.
You need the oil to fry, but yeah, otherwise you just kind of get.
Well, some people are greasy enough as it is, so
that's true. Yeah.
But seriously,
okay.
So what you're doing basically is when you cook your food, you're using a very short wavelength at very high power, and that, believe it or not, is how you get your signals for TV from space. So you're talking in the gigahertz range, which is millions of cycles. So think about this: 144 megahertz.
Giga should be like billions of cycles, isn't it?
If you think about it, 2 meters is 144 to 145 megahertz. That's 144 to 145 million cycles. So I was brought up as an old style radio amateur. If I want to visualize a frequency, it is millions of cycles, up and down, up and down. It's a wavelength. And it's just a small portion of the spectrum. Light is a wavelength. Infrared radiation is a wavelength. X-rays are a wavelength. So that's why some of the astronomers say, I don't use the visible wavelengths. I look in the infrared, ultraviolet, X-ray. They're all part of the EM spectrum. So, by
electromagnetic
spectrum, that's right. And what we see as visible light is such a small portion of it.
It is
minuscule when you consider what's out there, really.
We were not very efficiently designed to see.
No, we're not. I think Dr. Alice Roberts once pointed out the human body is not a very efficient design when you actually look at it. Well, today we are restricted to that.
Yep. Let's roll along. I got something for this. I got a sun thing to show you. There are sunspots on the sun. Not just one, but lots. 2 groups. One of them designated active region 2719. Now, the spots are small. There's 2 groups right around the equator, starting to get a little bit past the meridian, though. So each one, I don't know, maybe 10, 20 spots or something like that in each group. There's 2 of them. One's north and one's a little south by, a tenth of the sun diameter, something like that. So most spots I've seen on the sun in a long time. Interesting to look at, see how many they actually count. Maybe Space Weather will mention something like that. But here's a picture of it. If you want to see yourself or you're just listening in, go to the SOHO website. NASA's SOHO Space Observatory satellite. And go check it out or get your scopes out and see if you can see some of the spots in these 2 groups. Nothing's really big, but the spot groups, the 2 separate ones, are fairly large, actually. So should show up fairly well in a telescope, properly filtered, of course.
Yeah. Now, saying that, I came across an article from a bunch of fellow astronomers from down under, from my friends in New Zealand. Now, there's a new telescope. Let me just put the link into the chat room. Okay, so there we go. There's a new telescope that's going to track down Earth's mini-moons. Not a mini-me, a mini-moon. And before we go any further, the show will be posted via YouTube on the AFM Facebook page. Okay? So that all the links will be there too. I just want to thank StarStorm for gathering all the links as we go through tonight's show. So, these are Earth's mini-moons, is that what you're saying? Earth's mini-moons. Right, Earth's got a lot of them. Well, whatever happens every now and again is the Earth captures a small asteroid in its orbit. It's called a mini-moon. Since it's actually technically small and it's really a temporary natural satellite. Now, eventually, these astronomical bodies venture back into the solar system after a brief period of capture by our gravity. So a new telescope called the Large Synoptic Survey Telescope, the LSST, is being programmed to pick up on these tiny, fast-moving objects which resemble asteroids and will be tasked with finding such mini-moons. Now, the first and last time they actually observed one was about 12 years ago. It was in the form of a visiting asteroid called 2006 RH120. Now, this one actually enters our planetary orbit every 20-odd years before continuing its path around the Sun. So they've decided that obviously this is happening a lot. Now, since the revolutions of these mini-moons around the Earth is very infrequent and irregular, so spotting them and tracking them with current technology is dependent on chance rather than capability, the study goes on to state. Now, the LST is currently being built in Chile and is expected to be up and running in a matter of about 5 years. When it's actually complete, the telescope will be armed with a giant mirror to pick up faint light signals from near-Earth space, combining with a large field of view to capture the actual space objects. So they go on to describe that a key objective of the telescope project is collecting samples of minerals from mini-moons to study on Earth. It also describes an entire futuristic mining industry that is dependent on these fledgling asteroids, which is going to be an ambitious goal for an exciting new astronomical technology.
So this telescope is ground-based then, I'm taking
Ground-based, yes. It's in the Atacama Desert. It's one of the highest and driest places on Earth.
It's in Chile, I believe.
Yeah, Chile, yeah. I'm getting a funny look from StarStorm here.
And if we're going to be building stuff in space, we won't be able to get the resources from Earth up.
Exactly. As StarStorm is pointing out, if we are ready to start building habitats in space, it's going to be prohibitively expensive to lift the stuff out of the gravity well, when the material could actually be sitting there waiting to be picked up. Now, Black Projects has put in to the chat room that the LST, they reckon it's going to generate around 15 terabytes of data a night. That's a night. When you consider how many petabytes that Merlin, the square kilometer array, already produces, and never mind what happens when we actually do link up all the Earth's telescopes to form one huge array. I
wonder if they could put a couple of small satellites in those points, those Lagrange points, and like motion detectors on them, and so something happens to come into those little stable gravity spots, will automatically detect it. And of course, small satellite with cameras on it would be nice too, and image them directly. Just wait for them to show up.
One, you're going to have to really, really think about how you're going to program it, because space is not empty.
Right.
When you think about it, there's a lot of dust up there. There's a lot of grain-sized objects. These are the sporadic meteors that we see during meteor showers. They can come from any point of the sky.
But it's more concentrated, is part of a meteor, a comet stream, though.
Yeah, the regular displays are cometary in origin, and every now and again the parent comet comes home, or the parent asteroid or near-Earth object comes back a visiting and tops up the reservoir. But a lot of these sporadics are just random pieces of space dust or grains of material which just enter the atmosphere and give it a brilliant display. Some of them are actually quite sizable, and they do generate bolaids, which really do make people sit up and take notice.
I wonder if we could put like some CubeSats in those points. That'd be easy enough to do.
It's possible, yeah.
Yeah, a simple little motion detector from Radio Shack. Oh, wait, no more Radio Shack. That wouldn't work. Yeah,
Radio Shack has unfortunately come and gone. I think there's a few stores and a few places still open, but...
Might be some online stuff, too. I haven't checked it in a while. That'd be kind of a good CubeSat project, I think. Put them in the L points and see what's there. Wait for stuff to come in and out.
Yeah.
That'd be fun. All right, let's see. Speaking of cometary debris and stuff like that, let's go to the comet that's coming around. How about that?
Yes, Aqua, for you, we are live.
Yes, we are live. Giacobini Zinner.
Oh, my friend 21P. I've actually been imaging it recently. I imaged it a few nights ago.
Have you?
Yeah.
Oh, nice. I need to get out, and we've had some rain and stuff like that, so not really good clear skies on the weekend. That's been useful. So I need to get out there and get a look at this comet. I've seen it before, way in the past, but nothing lately. Let me put a link of. Let's see. It's kind of its orbit, which is an interactive chart. So you can actually click on it and drag it, so you can look at it from different angles and stuff like that. And then I also have a star chart through the end of the month. Let me put that in there too. I want to point out something on the star chart. Let me put that. It's all going in our chat, which of course will go onto our Facebook page and our web page. Facebook page.
Okay, so
website's not working right. Fully.
That's
right
all right.
now.
That's all right. I can.
Yeah.
There's a. Oh, that's quite a large link, isn't it? Okay, so what I'm going to do, I'm going to put a link into chat as well for 21p. Because I've gone to the Sky Live. Now, I actually use the Sky Live a lot when I'm doing my imaging runs for comets.
Okay.
Because the nice thing about it is, you actually can pick when you know that you've got time on the telescope. You can set this to the date, the time, and you can see what is where it is and if it's actually visible. So obviously I spend a lot of my time imaging through the Canary Islands or through Siding Springs. Occasionally I go to Mayhill and to Sierra. But as I say, I really love the Sky Live because it gives you an awful lot of information. So right now it's telling me that 21p Jacobi Zinner is somewhere in the region of Perseus, and the radiant is close to the radiant of the Perseids. But as I say, it gives close, you. Yeah. The really good thing about this site is that it tells you if the shower is active or inactive. So at the moment, of course, the Perseids are now inactive. Yep. We've reached the peak, and it gives you a very good idea. So let me just zoom in a little bit. And so the nearest real star is going to be
but actually, if you give it a week and a half or so, actually right around September the 4th, something like that, it's going to pass right by Capella, Alpha Auriga. I mean, like really close to it, looks like within a degree or so. Yeah. That'd be a cool way, an easy way of finding it, and that'll be a cool observation too. You could pick that star out in the northern hemisphere pretty easily, pick that star out, go right to that star and see the comet there. No problem. Instead of hunting through a very rare, poor star field and trying to star hop if you don't have computer assist on your scope and stuff like that. So it's kind of in a big open area of not too many bright stars right now, but it's getting there. So kind of between, it's just past Cassiopeia, kind of going to pass right by Perseus and then head, like say, right to Capella, but right around September the 4th or so.
Well, right now, looking at the Sky Live, I think it's in Campopelades. It's between Alpha Perseus and Beta Campopelades. It's in that space just there. So, okay, I got totally and utterly bored this week.
Okay.
And I decided I was going to, just for the heck of it, and because I wanted to, I went and imaged a star.
You imaged not just any star, go ahead.
Okay, so what I did, I went for Gamma. Let me pull up my notes. Oh, come on.
Third Gamma brightest?
Aquila.
Gamma what?
Gamma Aquila. Better known as Terra-Z.
Okay. Is that one?
There's a link to the star Terra-Z. And yes, you got to zoom around it.
Is that one of the stars on either side of what's the bright star in Aquila? What is that star? What's Alpha Aquila?
Alpha Aquila. Oh my god.
Yeah. It's okay. We got Deneb, Vega, and Altair. Duh.
Yeah.
Okay, so is it one of the two stars next to Altair?
Okay, so let me just pull up my constellation.
All right.
Okay, so...
And I'll just pull up Stellarium. And let's see what I got. We're nice quick star charts we got here. It's like Stellarium.
Okay, so Altair also designated Alpha Aquila as the brightest star in the constellation of Aquila and the 12th brightest star in the night sky. So,
Beta, it's alpha, beta, we want gamma. Okay. Alshane is beta, and it's Terrazed.
Terrazed, yes, Terrazed. For anybody who actually ever watched the series Andromeda, you would probably guess I was in one of my... Let's image a star that's been in a sci-fi show.
Those are fun.
Yeah. I've somewhere in my collection, I've actually got Epsilon Eridani, which is the home... According to Gene Roddenberry and most of the Star Trek writers, that's the home star for the planet Vulcan.
I always wanted to look up that one that, the original series... where McCoy says, I know a place on so-and-so third or fourth or something like that where and then he kind of blanks off. He doesn't describe what the service is like.
Yeah. Okay, so Gamma Aquila, also known as Terrazed, is a star in the constellation of Aquila. It's an apparent visual magnitude of 2.712, and it is a naked eye object. Surface temperature is 4,210 Kelvin. It's a mere 394.6 light years. It's a spectral type K32. So the UV color index is plus 1.720, and the BV is plus 1.500.
Alpha's easy to spot, and there's two stars, one star on either side of Altair, and Terrazed is the star that's on the western side of Altair.
So, as I say, it's in the Aquila the Eagle. It's in the eastern sky at nightfall. It's the brightest star. Our star is to the bottom lower right. And the star named Terrazed, according to stardate.org, is just above Altair. It's a giant star that's nearing the end of its life cycle.
Terrazed is, or Altair is?
Terrazed is.
Terrazed, oh, wow. What's the spectrum? What was the spectrum on it?
Okay, this one second. Let me just put that link into chat. As I say, it's just one of those things I got.
Color index.
It's an impulse imaging. Thank you, StarStorm.
Color index is B to V. No, that's not right. This doesn't say what it is.
K32.
K3. That's really red.
Yeah.
So that would mean that, and if you said it's near
red
the end of its life, a red giant star, that is correct. Yes. So it's red because it's gotten used up its hydrogen and
its helium.
Swelled up and cooled off, and that's why it's red. So more of the red giant star of the old type of red giant star.
It's probably a contender. It's probably almost at the same point in his life as Betelgeuse.
Mm-hmm.
And so that we have two potential contenders for some brilliant pyrotechnics.
Well, depend on the mass of the star, though. So it could be big and red, but not very massive. So if it's not real massive, it will just basically become a planetary nebula. But if it is real massive, we could get a good supernova out of it.
Yeah, which should be quite nice because, again, the other places we're watching is in the southern sky.
Mm-hmm.
And of course, I can't remember its name right now because I've actually imaged this so many times through Siding Springs. It's the Homunculus. I forget what it is.
That sounds familiar. Yes.
Yes. It's the one that if it really does go.
Eta Carina?
That's it, Eta Carina. That's it. Thanks, Marty.
You're welcome.
Yeah, the Eta Carina Nebula.
Mm-hmm.
If the star in the center of that nebula really does blow its top, they reckon it's going to be very, very spectacular, certainly from the planet Earth.
Mm-hmm.
We will definitely know all about it, even in the northern sky, even though it's a southern sky object.
Be worth traveling south for.
But the thing, if that goes, we will know about it even in the north. So it's one of those candidates that everybody watches patiently, hoping either it's going to go out like a wimp or it's going to be a or an almighty flash, and we will definitely be rewarded.
Mm-hmm. Well, we're halfway through our program, so let's do a little station identification. You are listening to the Event Horizon here on Astronomy.fm radio, about halfway through our program. It is 9:30 in the evening on August the 24th, 2018, from the eastern portion of North America. So universal time, that would put it about 1:30 in the morning, Saturday morning, August the 25th, 2018. Forgot to say hi to everybody in our chat room, so I think we're going to do that right now. So it's you and me, Nick. Got Glenn, Evil Spock, Optronics, Miker. I don't think we've had you in here before, Miker. Aquafew, StarStorm. All right, welcome everybody, and glad you're here. Want to remind everybody we've got more programming coming up after Space Pirate Radio, and we repeat these programs for every 4 hours for the next 24 hours. So,
now, whilst we're on the subject of comets,
yes,
two other comets which are really, really worth keeping an eye on. One of them is the one I really hate to pronounce. You know which one I made the.
Put it in our chat room if you can, and I'll pronounce it for you.
Okay.
Already did Jacobini's.
No, it's not Jacobini's in it. It's 29p
Schwassman-Wachman.
Yeah, whichever.
Yeah.
Okay. The nice thing about this particular comet is that it goes through a regular outburst.
Mm-hmm.
Now, at the moment, of course, it's sitting somewhere around 14th magnitude. It needs a very good telescope. It needs a CCD, and yeah, you can get some decent images. However, it does go up and down 1 or 2 magnitudes.
Mm-hmm.
And the other thing, of course, is it is relatively close. It's a Jupiter family comet, and it's one of those that a whole bunch of us in the comet community really, really want NASA or ESA to send a space probe to.
Mm-hmm.
Why? Because when it does go, the amount of fresh material it gives off is quite incredible.
Mm-hmm.
And the other good thing about it is everybody says, oh, if it's a very active comet, it's a danger to a space probe. Not really. We have been mapping this comet for, I think, the past 10 years. We know its frequency and outbursts fairly well. We're getting better and better at predicting them. And, of course, the chance to see some really pristine comet material would be absolutely brilliant. And, of course, it also means the space probe doesn't have to go too far from home.
Mm-hmm.
Yeah, it's still a couple of hours round trip on the signals. But having said that, it's still relatively close speaking. And it trundles around in its orbit between Saturn and Jupiter, and it never really fails to impress. And right now, it is actually quite close to Neptune. It's above Neptune in the sky. Okay. That's why I put that. If you look at the planetarium link, you'll see exactly where it is.
It's actually near the head of the western head of Pisces the fish.
Yeah. It's actually quite close to Beta Pisces.
Mm-hmm.
Now, the other comet that I know, this is actually becoming the subject of a PACA, which is a Pro-Am collaboration, I'm told. So I'm going to put this into the chat room, and this is 46p Vitron. Let's give me a couple of seconds, and I'll pull up a link for you. So again, this is at the moment it is a faint comet, and it's got a chance of perhaps putting on a little bit of a good display.
Kind of flaring up, you're thinking, or just getting in the right position?
It's just getting in the right position, really. At the moment, it's at 16.6. So, yes, it is. I don't think this is going to go naked eye. To be honest,
I don't think it's going to be telescopic for a while either.
It is telescopic.
Well, photographically.
I've imaged it, and I know a whole bunch of people who've actually already imaged this comet. And it is quite a decent little nucleus, and it's got a wee bit of a tail.
Mm-hmm.
So, as I say, this is definitely one to keep your eye on. In fact,
that's 26p?
It's 46p.
46p, I meant, yeah.
Yeah. Okay. So, as I say, I'll pop a light for the geeks in the chat room. I'll put a light curve in. It's expected to get. It's going from magnitude 25 as of January 2018, and it's thought it's predicted to peak at magnitude 10 or just above or just slightly more by January 2019. So here we go. Here's a light curve for you.
46 p. Not 48. I don't know. Find her chart in our chat room here if I can find it.
Sky Live, that gives you a planetarium chart, and it tells you exactly where it is in the sky against the constellations.
So I was going to get us zoomed in on chart here. I don't have it on my list.
It's in Cetus at the moment.
Okay.
It's just slightly below the middle of Cetus.
Alrighty. No, it's not listed on my list of comets in the sky right now, so
no, it won't be.
Not an extensive enough. It goes pretty faint.
Yeah.
This list gets down to 16th magnitude or so, but
and the rest.
Not happening. And the rest, yeah.
Yeah, at the moment, it's JPL magnitude estimated is 16.2. It is definitely it's definitely a decent size, a decent telescope. It's definitely a CCD, and you're definitely going to be doing the Staccaroonies and the flats and the darks and the lights to get this comet. But it is worth it. So
see what happens. See if it comes around.
So you see that? Yeah, the first link I put in, the info link, gives you an idea of its orbit.
Okay.
So this one goes all the way out to Jupiter and comes to just within to all the way into Mars.
Okay, so it never really gets to much of the inner solar system then.
Well, it doesn't really leave the inner to mid solar system. Right.
So it's saying it's not a highly elliptical orbit. It's a little bit more circular.
Yeah.
So it doesn't really get that far away.
It's an egg-shaped one.
Yeah. Okay. So not real close, but we'll improve later, hopefully. So that'd be nice. How about we go with like what's happening with some planets and stuff like that?
Well, I last night I did go outside on the front porch, and I did see the moon and I did see Mars.
Yeah, me too. That was nice. It was supposed to be about 7 degrees separation between the two, so definitely easy to see.
Oh, yeah. Very rare.
Sunday we got full moon, so forget about some deep sky observing this weekend.
I don't know. You can still do it if you're looking into the opposite direction.
You can do it, but not as well.
If I got the chance, if I can get slots, I will still image. I tend to go. That tends to be galaxies, really. Around full moon time, decent galaxies. Maybe some edge-on spirals or something like M51. That's always, that never fails to show a decent image, even at full moon. It's just a case of making sure you don't point the telescope towards the moon. But then again, you see, I will point the telescope at the moon.
Because you want to see the moon.
Because I want to see the moon, yeah, basically, Marty.
But then again, full moon is not the greatest look at the moon type of time.
No, but there's still things you can do.
Yeah. Libration.
Libration, I think, is the greatest thing since sliced bread. Thank you.
You got to explain what libration observing is on the moon.
Well, libration observing on the moon is when the actual tilt of the moon allows you to see just that little bit further round. Like when you can see more of Mare Hombarium, of Mare Smithii, because of the way the moon is actually sitting when it faces the Earth. You can get a north-south libration as well as an east-to-west libration.
Yep. So east and west is usually caused by the orbital speed of the moon.
Yeah. But it's one of those really wonderful things that if you get your apps up and running, you can sit and say, okay, if I want to get Mare Smithii, this is when I've got to be out there. Sometimes, it's going to be a daylight moon. But you know what? That's the greatest thing. Planets, the moon, you can do them in daylight. You don't need a dark night to do them.
Yep. We got...
Just interesting as ever.
Mercury in greatest elongation, western elongation. That means it's up early in the morning before the sun rises. So mostly favorable, a little bit more favorable because the ecliptic is a little bit higher for Mercury. So that would make it a little bit more visible. That's Sunday greatest elongation. I also noticed that I think we just passed Venus's greatest elongation too last week, and I was thinking, well, it was greatest elongation, but I'm really having a hard time seeing it. I'm trying to figure out why, and because when Venus first started coming around, the ecliptic was almost perpendicular to the horizon. So even though it was closer to the sun, but it was higher up, so it made Venus much easier to see. And then as time went on, and Venus got around the back of the sun and to its farthest point away from the sun, which took several months to do that. Well, the ecliptic got lower and lower and lower. So actually, as Venus got farther from the sun, it got closer to the horizon. So that kind of threw everything off and made Venus a lot higher to see. I used to be able to see it over the buildings looking out my front door, and now the whole time it's out, it's been below the buildings, and I can't see it anymore. Just by changing the angle of the ecliptic, it's done that.
So one of the things which ceases to amaze me, Marty, is I'm going to visit this again because it has reared its ugly head.
What is this?
This is we never went to the moon. It's all done on a Hollywood soundstage. Capricorn 1 proved that. Well, the thing is, JAXA, when they sent their Selene probe, as it was initially called, around the moon, completely and utterly blew the hoax series out of the water, because one of the first things that the Japanese Space Agency did was to image around the landing sites. And you can see the lunar rover tracks. You can see where the actual descent stages are. You can see to a point where everything was. You can see the packs that were left behind by the astronauts to monitor for moonquakes, the mirrors for the laser ranging experiments. They're all still there. Most of the instruments are still functioning. And every now and again, they still actually shoot a laser through a telescope to one of these mirrors. It bounces back, and they tell you the exact distance between the Earth and the Moon. Now, I had one person tell me very confidently, they were put there by robots. Well, that must have had one heck of a long arm in order to place the mirrors and the actual lunar experiment packs where they did. They were not put close to the lunar modules. They were actually carried a fair distance. The reason being, when it came time to leave the moon, they didn't want these experiments damaged by the blast. So they had to put them at a considerable distance. These experiments, to some degree, still function. And the greatest thing is they're still telling us information about the moon. Some of them are still recording moonquakes. And in fact, the most important thing was space probes like LRO and LADEE, their ultimate fate was to create a moonquake. And of course, the same happened with Selene. It was impacted, and they were looking for the flash so they could run spectra. Why are they doing this? Well, because they're looking for water. There's an article here from the BBC. And one of the things which really makes me laugh is these manned landings on the moon happened at the height of the Cold War. What is the first thing that China and Russia are going to do when they're following the missions, the radio signals, the hardware, and it doesn't land on the moon? What do you think they're going to do, Marty? Marty? Is Marty still with us?
Yeah, I'm still with you. Sorry, okay. I had it muted for coughs. They're going. Yeah, they would tell what we were doing.
Yeah, They would be screaming at the top of their lungs, the Americans faked the moon landings. That would give them the Cold War win.
And then after the mission, what did we do? We gave them moon rocks to study.
We gave everybody moon rocks.
Right. And then they studied them, and they said, this is from the moon.
Yeah. And the reason we can do that is because we have meteorites which we know have come from the moon. They've been ejected from impacts on the moon. They've survived the trip to the atmosphere, and they've landed sometimes violently, sometimes not so violently.
Well, when you got a rock that we claim came from the moon, and we say that somebody looks at it and studies it and says this is not from the Earth.
Yeah,
that's pretty much a conclusion right there. It's not of this Earth.
And the greatest thing was the samples that Apollo 11 through 17 brought home. They were looking at they were using mass spectrometers. They were looking at the signature of the materials.
Mm-hmm.
They were looking for isotopes and minerals which either were formed through extreme heat and violence,
mm-hmm.
or they're looking for materials that have been affected by the solar wind,
mm-hmm.
which can change the isotopes, which would then be discovered.
Mm-hmm.
So, of course, the obvious thing to do is to compare it to samples of similar materials on Earth.
Mm-hmm.
And one of the things we found is there are minerals which exist on the moon which were found on the Earth. Olivine is one of those minerals.
Mm-hmm. Which I'm going to segue into another article on olivine when we're done.
Yep. There's a question in the chat room. Do you think the Chinese will get to the moon next? I think it's either going to be SpaceX that get there, the Chinese, or the Indians. The Indian government is ramping up for their first manned space flight like nobody's business.
I got a feeling China might go to the moon, but might not be a successful mission.
I wish them the best
feeling.
of luck, actually, because the more nations that can actually seriously explore space, the better. And I wasn't very keen about commercial space travel, but when we're seeing what Musk has done, what Steve Bezos has done,
mm-hmm.
I have to admit, I am dead impressed that these guys have thought that it is worth sinking their own money, and that they've convinced their shareholders to sink money into it. So yeah, I think it's brilliant that everybody is trying to get to the moon, trying to land on the moon, trying to explore the moon, and I really hope that perhaps the docudramas like Journey to the Planet, Voyage to the Planets, Defying Gravity, etc. They will eventually happen as a multinational expedition, because I really don't think any one nation can afford to be doing it alone. It is going to have to be a cooperation between other nation states.
If you like reading a lot of science fiction, you'll find out most of the science fiction stories about like colonies on Mars and stuff like that, they're all corporate colonies, and of course they always run into corporations having to sacrifice their colonies for profit, and a lot of the things like that.
Well, let's face it. The people who so far seem to have got it right has been Arthur C. Clarke,
mm-hmm.
Isaac Asimov,
mm-hmm.
to a degree Robert Heinlein, because the three of those were the proponents of human exploration of the solar system and of space. Most of their stories revolved around exploring outer space, inner space, in different methods.
Mm-hmm.
And in a lot of cases, they were proponents of multinational crews.
Mm-hmm.
So yeah, Arthur C. Clarke is kind of special for me, because it was him, James Burke, and Patrick Moore that actually got me involved in this. So yeah, the moon has a soft spot, and certainly the science fiction from Arthur and Patrick does as well.
I lost interest in the moon when the nuclear dump lit and shot the moon out into space away from the Earth and the sun.
September the 9th, 1999.
There you go.
It shows you how much I enjoy that story, that series still. I have it on DVD. Yes, Spock, have a drink, dear boy. Have a drink.
All right, let me get this one or a couple articles in here. We're talking about materials, and here's one. Let me bring it in comments and stuff like that. Let me put that in chat. Here we go. Where are you? There we go. Primitive meteorite brings scientists closer to understanding solar evolution. Is a composition of a certain type of meteorite that formed under a couple different conditions, which show that it's actually a meteorite basically that came about from the early formation of the solar system, and it didn't quite have the same type of chemical, chemistry into it that would be like when you have asteroids smashing together, or parts of a couple pre-planets smashing together, where you get the right type of chemistry that it looks like some crust, looks like some interior stuff. This is a meteorite that suggests that by its chemistry that it was probably part of the original solar nebula.
Yeah,
went through a couple of processes.
Yamamoto 793261. It was collected from an ice field near the Yamamoto Mountains during the 20th
Japan.
Japanese Antarctic Research Expedition 79. Now, I think what you're referring to, Marty, is the amboid olivine aggregates.
Yes.
And the scandium and zirconium and quartz.
Mm-hmm.
And this mix can only really be condensed. The AOA, the amboid olivine aggregates, can only really be condensed from nebula gas to solid.
Yep.
So we're looking at 1500 to 900 degrees Celsius.
Mm-hmm.
And this aggregate's the first of its kind to be found in our solar system.
Mm-hmm. So not something that formed by the collision of fairly large bodies, but something that was formed basically from the very first gases that were coming together to form the solar system, basically, in the sun. Yeah. Now, I think that also similar or possibly from the asteroid Ryugu.
So
so that's what they're saying. By combining ongoing research on meteorites with results from Ryugu, we hope to better understand the thermal events, transfers, and mass that occurred during the beginning stage of our solar system. Let's go to JAXA then and get the latest, semi-latest images of this asteroid, Ryugu. All right, let me put this into our chat room here. Now, remember when we first started talking about them, they were like really far away images. And I thought, well, man, it wasn't that far away. It was only like a few hundred miles, but the thing was like a dot. So it was like, they've got some pretty wide angle cameras for this mission. Usually they want, they're loading up, 1,000 power telescopes to look at asteroids and comets and stuff like that. This one had some really wide angle cameras on it, but it's getting really close to it. Some of the images from 6 kilometers, would that be 4 miles away?
About that, yeah.
Yeah, something like that. So you can see what it looks like. Definitely a little bit more detail on the rubble pile effect. So if you kind of use your imagination, just think of this one possibly was formed out of the original debris of the beginnings of the solar system. So a lot of dust and small particles basically combining together, too small to compress down together and form a solid core or anything like that. So mostly sand and rocks is what it looks like. Kind of just
an aggregate, really.
Yeah. Stuff
conglomerate. Yeah.
Yep. Collected together, and if you think about it, like the stuff was like the loose stuff that was floating through our solar system that combined together, stuck together, but didn't actually chemically change.
Now, you're saying this, Marty. This reminds me of a lecture a few years ago I went to at the BAA Comet and Minor Planet section at the Open University. I think it was Simon Green who was saying that a lot of these asteroids or It may actually just be conglomerations of rubble.
Mm-hmm.
Now, a lot of people are like, what? He says basically, if you think about it, you get when you start getting stuff in space, as it goes through space, it collects material,
right.
And that gives it a little bit of assist from gravity. And once you get a little bit of gravity going, it collects more and more. Now, whether or not some of these places are actually solid is yet to be determined.
Mm-hmm.
So what you could have is a conglomeration of rubble that is sticking together under its own gravity.
Mm-hmm. Just barely.
Just barely, yeah.
It's really small.
And in a lot of cases, it is also very temporary.
Yes.
But temporary in the lifetime of a solar system can actually be very long-lived. For instance, the picture that's actually shown of Ryugu, 1 pixel in Figure 1, it corresponds to about 60 centimeters in real life. So that kind of gives you an idea of the scales involved.
Was it about 2 feet?
About that, yeah.
Yeah, 30 centimeters per foot. That's right. So about 2 feet per pixel there.
Yeah.
It looks really lumpy. And this thing's supposed to land and pick up a sample of it.
Well, yeah, it's gradually getting lower and lower.
Yeah, but they're gonna have trouble with this one because it's rocky.
But the thing is, they said that about Philae. They said, no one's ever going to successfully land a probe on the surface of a comet, but yet Rosetta did it. And the thing is,
it had issues, but it did
issues, yeah. But the thing is, you learn from those issues. This is the great thing about science. You try something, doesn't quite work, and you notice what did work and what didn't work, and you go back to the drawing board. And in a lot of cases, with missions like Rosetta, like Hayabusa, you literally learn from every encounter. So the lessons learned from Rosetta are being applied here. They're going to be applied by OSIRIS-REx and Bennu. So if you think about it, every mission is a stepping stone. So the next mission gets better and more successful. And so down the road, you're actually going to have a situation where you might have a mission that is a 100% success because you've learned from the past. And as they say, if you don't learn from the past, you're doomed to make the same mistakes in the future. But
I do that all the time.
The space agencies can't afford to do that. They can't afford to make those mistakes. These are multi-billion-dollar mistakes, and that is funding they just cannot replace if they mess up. So yeah, every mission teaches a new lesson, and the lessons from Hayabusa, from OSIRIS-REx, will go on to the next series of missions, and eventually they will get applied to perhaps a manned mission to Mars, or even to the asteroid belt. We're using the Orion capsule. Yeah, that'd be nice.
So right now they're trying to find a good, safe spot or favorable spot to land that rock's bigger than the feet of the thing. So it could be a little bit of a challenge, I'm thinking.
Well, as I say, that's the greatest thing about it. The biggest challenge with Rosetta was, are we gonna do this? Are we actually gonna get there? Are we gonna go into orbit? And then are we going to successfully land Philae? Philae bounced and tumbled and got lodged in a very bad position where it could not get enough sunlight to really do its job. But it did enough science in the end home.
But less than battery power.
Yeah, don't always depend on battery power. We've proven the safety of the SNAP, the strontium-90, the plutonium batteries with missions like Voyager, and the fact that the space agencies really do know now how they have to apply the safety standards and exactly what they have to do.
Exactly.
And the thing is, it makes it a safer technology to use because we've used it before. We know what to expect. We know what we have to do if there is a containment issue.
Hey, Nick, we might have to put our red shirts on unless you call up right now.
This is the away team to Captain Savick. 3 to beam up.
Thanks,
Energy.
everybody.
Good night.
Thanks, all. Appreciate you being here tonight. See you all next week. Good night.
Good night, everyone.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.fm Radio.
Hi, this is Tavi Greiner, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true, every little bit counts.
AFM. There I was, doing my thing, and all of a sudden, wham! Astronomy right between the eyes.